May I request everyone's attention towards the session? Thank you very much. I'm Nikita, and the co-founder of SIA-INDIA, an NGO which is working in the space education domain. I take pleasure in hosting the track 2 of all 3 days of India Space Congress. On that behalf, we have a wonderful speakers here today and talking about one of the really important topic, I could say. And then the topic goes like this: it's space missions, modeling and risk mitigation. Developments in computing, modeling and simulations allow us to understand complex system behavior, especially for space systems that are expected to perform in environments different from the engineering facilities here on Earth. This allows risk mitigation and performance to expectations for missions in space, be it launch or space assets. To talk about all these topics and what we have to do and how we have to progress, we have amazing speakers. To begin with, I would like to call upon Mr. E.S. Padmakumar, Associate Director of VSSC, to join us on the dais. Sir, please join us. I would also like to call upon Ms. Renuka Srinivasan, Brand Sales Director, SIMULIA of Dassault Systèmes India. I also request Mr. Kartik Kumar, CEO of Satsearch, to join us on the stage. Mr. Kartik Govindhasamy, co-founder and CTO of Antaris Inc. Welcome. Dr. Dibyendu Nandi, Head, Center of Excellence in Space Science, Indian Institute of Science Education and Research, IISER, Kolkata. Thank you so much for joining, and I would also like to thank everyone who have joined here for this particular session. I'd like to call upon Mr. E.S. Padmakumar, Associate Director, VSSC, to address the gathering.
Yeah, very good morning to each one of you, my fellow speakers and the participants for this very important session titled Space Missions, Modeling and Risk Mitigation. As we have more and more space assets out there, the security of those assets becomes paramount. Earlier it was few satellites. Now we know that there is an army of satellites out there. The constellations are becoming bigger and bigger. And there is a lot of money and effort that is really depends on the way we assess the risks in space. If you look at the LEO, MEO, and GEO orbits, we know that in LEO, there are certain risks which are more pronounced, especially coming out of the debris. There are certain risks which are less pronounced, which may be coming out of the space weather part and the radiation part. So the assessment of the risk is a very critical thing. And the assessment has two parts. One is to get the right inputs about the debris, the right inputs about from the modeling of the space weather. And combining these two, we get all the input data that are required for the modeling. But the modeling itself, the models that are involved, are very critical. to the final assessment. As we know, the age-old STK that has been serving us all these years for the conjunction analysis, the collision avoidance strategies, and overall understanding of the long-term and short-term risks. There are more software tools that are currently available, and more are in the pipeline. The methods of SGB4 as well as the new SDP4, which are used for different kinds of orbits, they are also familiar to all of us. The effect of the space weather was recently well captured in an event that SpaceX has painfully seen. Yeah, a bunch of satellites were put off, and so the space weather modeling becomes a real necessity if we are going to put more of our assets there. The accuracy of the TLE information, which we all use the TLE information to, and the high accuracy HSE information also coming from US for our analysis. The accuracy of this information also plays a very critical part. As far as the conjunction analysis is concerned, we used to have certain kind of limits of the probabilities on which we take a decision either to neglect it or take corrective action of doing an orbital maneuver for the spacecraft. Those probabilities has been traditionally limited to certain values. Those limits are also undergoing corrections as we do better modeling. So the area of modeling and risk mitigation is of very high emerging importance. If you look at the debris scenario, we know that the number of debris are growing, and we say that outside atmosphere there is a debris sphere also. And as Kessler had earlier told that it will be, as the time goes, it will be difficult for the mankind to go out of this earth, because this debris sphere will prevent us and putting very high risk on our journey. In Vikram Sarabhai Space Center, whenever we undertake a mission, we do two kinds of analysis for the ascent mission, that is starting from the launch point to the injection point. We do a study on what we call as a collision avoidance, whether the ascent vehicle has a reasonable probability of being hit by a debris on its path. And then for the released satellites, generally as a service provider, we do an analysis for the next 2 days for all the separated satellites. What is the kind of risk that they envisage? And if any of these risks are beyond certain level, we actually delay the launch. And there have been several incidents that we have delayed it by 1 minute, 2 minutes, then sometimes up to 5 minutes. If the launch window allows it, you will be able to delay the launch and get out of this risk. This is something that is being done in a regular manner. And luckily for the last mission that we had for the OneWeb 36 satellites on LVM-3, we found that, and we had just 1 second window, because that was a requirement. So here, we found that luckily we didn't have any issue as far as the collision avoidance analysis, both for the launch vehicle as well as the satellites. Coming back to this modeling and risk mitigation, I have four of my fellow speakers out here, and Ms. Renuka, Mr. Kartik Kumar, Kartik Govindhasamy, and Dibyendu Nandi. So all of them are experts in their own areas, and they are going to share with us their views about this upcoming very interesting area of modeling and risk mitigation. With these few words, we will start with this session, and I think Ms. Renuka is going to give us a brief presentation. With that, we will start off.
Hi, thanks everyone, and thank you for that. I'll try and keep it brief, but I did want to maybe quickly summarize a little bit of the space trends that we see, something we're all familiar with, and I think part of the reason we are having the Space Congress over here today. And then I'd like to briefly talk about, my company and why at Dassault we find, what we feel about modeling and risk mitigation, an area that we've been working with for quite some time now. Certainly, I think there's no introduction needed to the whole new space and the energy that we're seeing around the world, but especially here in India, with the kind of innovation that is going on. With respect to private parties coming in, private parties trying to look at massive launches, massive constellations that we see up there. But as he very rightly pointed out, when we look at some of the things like space debris and other aspects, there is also a whole sustainability angle which is coming into picture over here. And with more and more companies coming in, with the privatization angle, there's also a focus towards maybe some level of the cost. Keeping this in mind, we do see people looking at reusable vehicles. We do see the idea of having modular operations so that you could time to market, to launch can be reduced. And of course, there are other technology, newer technology people are trying to bring in to reduce the overall cost of the operation itself. I'm not going to go into each of these different segments. I think people are familiar, but one other aspect that I did want to bring out is as people get into maybe a little more far out the space tourism, and then we're looking at the deep space operations, and we're starting to look at human in space, then even more does the risk factors go up and the criticality of that risk mitigation become more important. And that's partly some of the things we're going to be talking about today. I'll just take a minute, a video that we have on the vision that Dassault has. I think our volume is...
Nearly 65 years ago, satellites were invented and captured the world's imagination and wonder. Today, the fascination has only deepened. It's a new frontier of satellite technology, where companies can now collectively extend the limit of rocketry and satellite innovation, making space more accessible. The race is on to launch satellites into space more optimally and sustainably. By bridging the real and virtual universes, you accelerate innovation, from rocketry and satellite design to manufacturing and operations, so you can deploy first-time right satellites into orbit. Go further and faster. Unlock new opportunities with the 3D Experience platform.
Thanks. So I think if you see what we spoke about, which is the first time right, I think in a way that is the risk mitigation angle that we are talking about. Very briefly, Dassault Systems is a company that's focused on science and technology. We've been in existence for about 40 years, starting from the aerospace industry on the 3D modeling and evolving through various, aspects. What we're focusing quite a bit on, besides our 3D experience platform, is about virtual twin technology. So we do have virtual twin of a city, Jaipur city and Singapore city, but we also are doing that with life sciences. So we also look at realistic human simulation, for instance. But what we'd like to talk a little bit more about is how we think a virtual twin of products could actually help in ensuring that we come up with better collaboration, more innovation, by allowing different disciplines to work together better, to have access to the same technology, and using that technology throughout the life cycle of the product. Right from the conceptual stage, when you are conceptualizing what you actually want, setting down the requirements for what will come out of the product, understanding the functional and logical needs that flow out of it, to the design aspect, which is where we're talking a little bit more today about the virtual testing and the kind of simulation you need to do, but also going further into the manufacturing processes, and later, of course, to the operations. And all of this with the overlying wrap of project management to ensure you meet your schedules. This is what we actually feel is possible with our 3D experience platform. And the idea is that the virtual twin that you build right at the early stage will also stay throughout the operation and the life cycle of this product. And what can you leverage out of this virtual twin? Basically, you can look at what-if scenarios that will allow you to perhaps better prepare for certain eventualities. It is an open platform because we understand there's a lot of legacy out there. We use multiple tools, not just from us, but from many other leading organizations, and therefore the idea is to allow you to integrate and collaborate with those solutions. And of course, this is something that is proven technology. I give here an example from Ball, where they have been using our 3D experience platform, and the whole idea was to accelerate their innovation, and also have a digital thread that runs through right from their conceptual design, product performance, and all the way down to managing even their physical tests on the 3D experience platform. In fact, one aspect that Ball really found useful in trying to accelerate the product itself was to search the information they already had for existing products and components which could be reused, because what typically ends up happening is you have multiple duplicates of the same component which have been used for different products. And one of the things is you could do a 3D based search for certain shapes and components which could then perhaps be used instead of being redesigned and tested again. When I speak about two aspects that I think will really help with space modeling and risk mitigation, I think the two for me are a system level approach, a model-based system engineering approach, and the other, of course, is virtual prototyping. So I'm just going to take a few minutes to speak about the fact that we at Dassault certainly believe that a system engineering approach where multiple disciplines can interact with each other, and where you have models that you can then use to understand this interdisciplinary approach, whether it's the requirements and how these different functions will then interact with each other. That is what is going to really help you in capturing some of the errors early in the cycle. In this slide, what you actually see, if you can see, I suspect you cannot see, is in the early conceptual stage is perhaps where about 70% of the errors come up. I apologize, I don't think it's actually that clear. But a lot of the other aspect of the errors show up where it's actually captured. 50% of the tests fail during the integration phase. Your vendor supplies something as per your specs, but when you integrate is where this is, really comes out. And this is why we speak about the necessity of doing a system level approach where multiple disciplines work together, and this is hopefully helping you capture your errors upfront in your design cycle, where also the cost of making those changes becomes less. I'm not going to spend too much time. We spoke about using a system engineering multidisciplinary approach to capture errors. The other aspect about it is, of course, just the virtual testing. So as far as virtual testing goes, I think simulation, numerical simulation in a way grew out of the aerospace industry. So hopefully most of you are familiar with the advantages of numerical simulations, but it does help us in trying to increase confidence on what we're doing, ensuring we have it first time right, and of course reducing the total number of physical tests tests that we actually do. At Dassault, we certainly believe in any domain, but especially in yours, it's important to include all the different physics that that might be relevant for your product. So not just say thermal, not just electromagnetics, but whatever other relevant physics. The relevant scales, we span from a molecular level all the way up to a system level. So you might need for certain applications to look at a multi-scale kind of approach. And of course, there might be different domains that you need to include. And so I think incorporating this where relevant into your design philosophy is very critical to again capture and have.
It's an open world, but really interesting.
Sorry, just give me a second there. So I just wanted to introduce this. This is a video from the Max Planck Institute of a launcher that they had launched, designed of course on our products, but it's more the scale of what they actually had to do with respect to launching it in 2004, and it actually intercepts its comet. It's the Rosetta spacecraft, and it put a lander, a Philae lander, on the comet itself. Now let me see if I...
It's an open world. But really interesting, I think, is this interaction in another gravity environment. You can't really test on Earth. And yeah, I think the simulations are essential, also in the future.
Launched in 2004, lands in 2014. The poor scientists had by then moved on to several projects. But so I think the biggest thing over there was more that they really couldn't do a lot of the physical testing on Earth because of the kind of technology available then, the microgravity testing that they wanted to. So, and in the interest of time, I'm not going to go too much, but we certainly have a booth outside. If you're interested, we can speak in more detail, and I'm sure during the panel we'll touch a little bit more on why virtual prototyping really will end up helping all of you in capturing many of these issues right up front, especially if you take this example of a CubeSat where you have, multiple antennas very close to each other in a small enclosed space. How does the geometry of this structure actually impact the performance? How do the multiple antennas interfere with each other? All of these kind of simulations can actually, help you in capturing some of the errors up front. And so for us, I think, we work with agencies throughout the world, many of them leading space organizations, both big and small. And we certainly work with agencies here in India as well. And we're proud to be associated with New Space and see how we can, what we can bring to the table to support this New Space here in India. And lastly, I think for me, at the end of it, it is the digital continuity of having the simulations and modeling right from end to end throughout the life cycle, from conceptual design through the manufacturing and then the operations. That will actually help with respect to a lot of the risk mitigation that we see. So with that, thank you. I don't know if you want me to...
Yeah, we will get into the panel discussion mode. I request Karthik to start.
Hi, good afternoon, everyone. My name is Kartik Kumar. I have the privilege of leading this panel discussion. Hopefully over the next half hour or so, we'll be able to uncover some of the... Testing? Okay. All right. So take two. My name is Kartik Kumar. I have the privilege of leading this panel discussion and moderating it. Hopefully we'll be able to touch on a range of interesting topics pertaining to the topic of this session. Just to tell you a little bit about myself, my background is in space engineering. I'm one of the co-founders of a company called Satsearch, and we're building an online marketplace for the space sector. And so digital is also part of our DNA. And I think the overarching topic that we'll hopefully cover over the next half hour is the importance of digital and processes associated with what's known as digital transformation towards what's going on in new space in particular. So the panelists who are here all have their own experiences and their own backgrounds and personal stories. And I think one of the interesting things that beyond the technical side of modeling and simulation and risk management is how people perceive it in the real world. And often I think we forget that space is a truly human endeavor. And so hopefully during this panel we'll also be able to touch on a little bit of the personal experiences of the panelists, and in that way humanize also this effort that we are undertaking to become spacefaring as a civilization. So I think to kick things off in that vein, probably I'd invite each one of the panelists to give their elevator pitch, and I would ask you to focus not so much on the technical side of things, but yourself and what brought you to the stage today. What's your background, what's your passion, and what's your interest that pertains to this topic of modeling and simulation and risk mitigation? So if I could ask you first, Dibyendu, to kick things off.
Sure. So first of all, thank you to the SATCOM Industry Association for inviting me. So I'm one of the odd persons out here. So I'm an academician. I was just joking to somebody that we count our blessings in terms of papers and citations, whereas you do it in terms of millions of dollars. So I did my PhD from the University of Science, way back in astrophysics, and then I spent about 7 years working in the US at the solar physics group of Montana State University and the Harvard Smithsonian Center for Astrophysics. My specialty is understanding the activity of the sun and its influence on the near-Earth space environment. I think this mic is going on and out, in and out. Okay. So I returned back to India in 2009, and when I returned back to India, I was trying to assess what is the landscape here, and how can I contribute in a way that is important in the Indian landscape, bringing something new in that didn't exist. And I figured out that space weather is a domain that there was very little understanding in India. Absolutely no groups working in the domain of space weather. So with the generous funding from the Ministry of Education, Government of India, I established the Center of Excellence in Space Sciences in India, which today is a pioneer in space weather modeling and risk assessment, not just in India, I think this side of the Atlantic. Well, you have European Space Agency, the Met Office of UK, and the NOAA Space Weather Prediction Center. I think the SESI is up there with this. So why should you worry about space weather? Well, this is not something that you normally see people talking about because you don't really see it, unlike debris. And I don't know whether you read this book called The Little Prince by Antoine Saint-Exupéry. It's a beautiful line there. What is essential is invisible to the eye. And it comes out of the blue from the sun. And it's only now in the last 10 years that we are trying to figure this out and understand and predict it. And as I will speak later on when Karthik starts asking the questions, this is something that every satellite operator should be aware of. So with this, I'll give the mic off and give it to others.
Yes, and I invite you, Kartik, to
Yeah, sure. Hi.
share your experiences as well.
Thank you. Good afternoon, everyone. So before I even start talking about myself, I think the topic is very relevant. As Ms. Renuka pointed out, why are we here? Why is simulation, modeling, and risk mitigation is important? So I'm gonna, with that context, I'm gonna say that if you hear the keynote speech this morning, you heard about number of satellites, the space economy. It's going from 500 billion to trillions and whatever number that's there. Those are all great. Those are all predictions based on the fact that the technology advances can actually enable to create that many number of satellites to be launched, and the downstream applications can be created, and therefore the GDP can be that number. That's a prediction. So can we do it? That's the question. Let's just park it for a minute. So my background, I'm coming from Planet Labs. I was CTO at Planet Labs. I was part of the team who actually designed and launched hundreds of satellites. And we did simulation, of course, but also we launched something called Agile Aerospace, where basically we go to space faster. We believe in simulation, but we also believe in learning from space faster. That's how we did that. And then during that time, if you really go back 10 years ago, what happened was the technologies that were available there was completely vertically integrated. Fast forward now, 10 years later, where are we today? Here is that do you have an investor-backed company that can give you hundreds of millions of dollars? Or we talked earlier before this session, is a billionaire can have his own money put in the company and have that investment to go. But not every new space company can afford to do that today. So how many new space companies can do that today? No. So our experience coming back from Planet Labs is that there's a constant reinvention happening. Anyone who wants to put their payload or spacecraft, it's a constant reinvention. Supply chain difficulties, disparate hardware and software. There is no software platform. So do analogy to what happened in mobile industry and PC industry. How did the Android phone go into the market? Today there are 3 billion active Android devices in the market. How about Linux disrupting the industry from previous operating systems, etc. So I'll go into the details later, but my point here is that there is a disruption, innovation that is required, and that is all tied to the fact that how do you risk mitigate before you even launch your satellite? That is again, can we have a platform that enables? Can we have a software and services and APIs that completely abstract the hardware so that all this modeling simulation that we talked about can be available to grassroots, folks from schools, folks from universities. You're all sitting there wondering, what is this all tool about? Can I even access to this? How do we make it happen? So we'll touch on this later on as we go through the questions.
Yeah. I am Padmakumar. I think this mic is not working. Yeah. I am from Vikram Sarabhai Space Center. I've spent a lot of time in mission design, simulation, and risk assessment of the launch as well as the initial period of the separated satellites. As has been pointed out, as we put more and more money out there, we need to make it safe, both at the time of design and at the time of operation. That's a challenge, and the ascent part is fairly known. The ascent part of the mission is fairly known, how to mitigate the risks that are associated with a launch vehicle mission has been an established area. Though there are quite a number of multidisciplinary aspects to it, starting from the propulsion, the structure, the separation systems, the acoustics, vibration, the thermal aspects, and all these interacting in such a way that we still have margins for the mission to have a fairly good probability of achieving its target. So this is the kind of, as has been highlighted here, there is no single tool that captures all these aspects as far as the launch vehicle is concerned, and maybe as far as the spacecraft operation also is concerned. We don't have a single platform to capture most of this. So what is done is typically for each area of these aspects, we have softwares which simulates that particular aspect of the technology, and it requires a team of experts to put them together in order to understand what is the risk involved in the play of the results that comes from the individual tools. So that is what makes the entire operation more and more challenging, and it takes a lot of human effort as of now in order to make this up. So these are my initial comments, and we will talk more about the specific aspects as Kiran gives us the questions. Yeah, that's all.
And Renuka, if you would like to be beyond the keynote that you gave, perhaps you tell us a little bit about your story and what kind of, what you're passionate about in regards to modeling and simulation.
Sure. No, thanks. So I'm Renuka, and I'm actually a civil engineer. I'm probably the only civil engineer around, I don't know. But I did civil engineering, and I focus a lot on the structural mechanics side, so I have my master's on the structural mechanics. I actually joined, for me, the fascination with modeling has basically been the idea that you can actually understand how your product behaves and virtually test it even before it goes out to the market. And I think the other fascinating thing for me, at least at Dassault, has been, I've been with them for 25 years. We work on everything, I mean, shampoo bottles to space. So you see how technology is applied across multiple, industries. And of course, space is especially, it's a harsh environment, obviously the risk factors are much, much more. So it's been very encouraging to work with our customers. We ourselves don't have hardware, so we work a lot with, I used to also be in California, so I used to work out with some of our customers in the aerospace sector over there, as well as, of course, here in India with some of the customers here, in seeing how to mitigate some of these aspects. So that's a little bit about me.
Great. So thank you for the brief introductions. So I'd like to play a little bit of a game. So let's say we look into the future. We're 10 years down the road, and we have better modeling and simulation that is pervasive across the industry. What is the one factor to you that will change about the way the space industry operates if we reach that goal? So I'm talking about, is it a matter of cost? Is it reliability? Is it lead times? Is it performance? Is it something completely different? What, in each one of your views, is the one thing, the one factor that you're passionate about or looking forward to or you believe is essential and that modeling and simulation will enable when we reach that, that juncture?
Yeah, it's a very interesting question. As I said earlier, the question is, what are we doing for the next 10 years? That's the question, and how it will help. So before we talk about the challenge today is, it's really the disparate hardware and software and lack of platform. So I mentioned about Linux-like platform or Android-like platform that enables ecosystem. If we do not have an ecosystem, if you do not have a software platform that people have access to and it gets into developers' hand, all these numbers are just numbers. So fast forward, if your question 10 years from now, what I would like to see is a software platform that completely abstracts the hardware and it's given to people as an open source, just like what Linux did, just like what Android did to mobile industry. If we have that in consumers' and customers' hand, and that creates innovation from school, from the colleges to the academic institutes and to the commercial needs, then all this closed ecosystem will go away. And you can actually mass produce number of satellites. And of course, along the way you improve, because if you have software access, then you can improve your model, improve your simulations. So at Antaris, we call something true digital twin into true twin. Why is it called true twin? Because you go from early days of your design all the way to launch, your modeling, your spacecraft. There are a lot of attentions being put on, modeling mission, what happens in like the day in a life of an orbit, but the often overlooked the fact is the physical behavior of the satellite itself. If you can actually create a model of a true twin of the satellite in somewhere in a virtual environment, and if you can learn from the day zero all the way to deorbit, then you basically solve the problem of your behavior analysis and bringing the data back into the loop, and behavior also will be the same way in the space. So 10 years from now, I like to see a platform that enables people to actually work like what they do today with Android phone and with Linux platform, just like how the satellite should behave in space.
That's a very compelling vision. Dibyendu, would you like to comment on what it is that you think?
From my perspective, you can build a Titanic, and if you do not know that you have an iceberg coming your way, you will sink. So I'll keep my comment very short. You want to go to space, you need to understand the environment that we're in. So 10 years down the line, I would like every space agency, every space operator to know and understand the environment that they're getting into and ensure that they are aware of the risks, ensure that they build in elements in their designs to be able to ride over a solar storm, a space storm, and extreme space weather. In other words, in 10 years, I would like all industry to be aware of and take account of space weather intelligence.
Great, thank you. Sir,
Yeah.
where will we be 10 years from now with better modeling and simulation?
Yeah. If you look at the spacecrafts, then as Kartik and Dibyendu has actually pronounced, a great software platform which allows the practitioners to play it out well, very well before they really commit the matter will be the best things to have. But when we come to space, there are a lot of things that are not very amenable to modeling. So it requires a lot of mathematical modeling. And in order to drive those models, we need a lot of much more data. And in order to, in fact, we find that certain simple things like how the thermal aspects influence the communication behavior. So things that we generally think that they are not really related comes out very live in the orbit. So modeling of such things requires a lot of innovation, and I think that those innovations should be thriving now as there is a lot of interest in this area. And with those mathematical modeling support, whatever Karthik has told will come alive. That's what I think.
Thank you. And last but not least, Renuka, where do you think we've arrived 10 years from now?
I think if I think your question was with modeling and simulation pervasive, assuming every industry department already has it. So certainly I think the impact would of course be, going to space maybe faster. But I also hope that people will use that opportunity. What we've seen, for instance, in automotive and other industries is you're never done. Right now you're making certain assumptions and you model because that's the level of technology, hardware and data you have access to. Once you bridge that, there's always something more that you've not accounted for. So people add more complexity into the system. I think we'll see that. But I also hope people will take the opportunity to try out newer technology which might become more available, more sustainable, newer materials, so that maybe reuse and other aspects will come. That's what I hope. Maybe the economy will drive us there. That's what I hope.
Great. Thanks. So I'm going to ask one more kind of warm-up question before we get into the detailed questions, and it's one that perhaps doesn't get talked about often, but I think is the reality if you're building a space company. So let's talk about budgets, right? So I'm the CFO of a new space company, and everyone in the team is asking me for a budget. In your view, how should I be thinking about budgeting, modeling, and simulation within my team? Do you have a mental model? Do you have a rule of thumb? Or do you have an approach towards thinking about the cost line item of modeling and simulation? And I'd love to hear from each one of you on this.
Yeah, so I've been there. So like I said, I'm coming from the Planet Lab experience too. And now from Antaris, we see customers looking into building satellites. So it's a relevant question, but before anyone can answer how much I plan for the budgeting for modeling, you should understand what kind of platform I'm talking about. It really depends, right? So if I go license an SDK software today, everybody knows what the cost it's going to give me. So it's known fact. That's just one piece of the puzzle. So before you even actually build a satellite, you have 15, 20 different entities that you're talking to, right? Like I mentioned, disparate hardware and software. And if you don't have a platform that actually combines them together, then you're talking about a cost that you don't even really know. So it's difficult with the current state of the space industry today. it's really difficult to predict how much I'm going to spend for modeling. And my experience, even the current company, we started off saying X number, now we are X plus X, Y, and Z, because the industry is so fragmented today that there is no common interfaces that basically mitigates all the simulation tools to be done on top of that. So that's exactly what we should be solving. And it's a roundabout answer to your question is that today it's very difficult to give you that number, but if you have a platform, predefined APIs that interfaces to all these simulation tools, then exactly I know what kind of simulation tool I need to really build my model, then I can give you a budget. That's what we're heading towards.
So maybe if I can just follow up also with you, Renuka. So there are, I'm sure, plenty of budding space entrepreneurs here in the audience. And they might not be able to wait until the ecosystem has reached the point that we have the optimal tools. They've got to make decisions today about how modeling and simulation sits inside their mission life cycle and their overall company's business model. So do you have a thought for them, something that'll help them understand how to think about modeling and simulation along with all the other things that they have to cater for in the business?
No, and I agree, while a number might be something that's a little difficult because it depends upon what they're doing, I would say two things. One, certainly in space, what we've seen at Dassault, for instance, is your number of analysts, the engineers, if you take the ratio of that with, say, an automotive industry. In automotive, you have more designers, maybe it's 4:1 almost. Whereas in what we found in aerospace is it's the reverse. It's 1:10. The number of analysts to end designers, because you buy a car for its shape, but you buy, when you're going into space, you need to have so many different engineers. So certainly I think the requirements for engineering software will be that much more. But I think we're at a great time now in the industry, because there is a, software as a service, you have cloud, you have things which allow this kind of collaborative environment without having to go into the deep investment that perhaps early, maybe a decade ago, somebody had to look at a HPC, a lot more investment. Today you get all of that in a way, any company, by providing, a cloud-based approach to modeling and simulation, many of which you could even buy per hour. At Dassault, we, have these kind of offerings. Most organizations also have certain special startup offers. So I think this way it's a great time, and I think with the pandemic we have seen even large organizations which have had some concerns kind of willy-nilly taking into cloud and showing that they've been able to work for 2 years on cloud. So I think it's proven technology. I hope they'll access it.
Right, so great, so the cloud is a potential option to enable scalability as well. Would either of you like to comment on?
So I think in the domain of modeling and simulations, there is a lot of expertise already existing within the academia and government agencies like ISRO. And I think this is a perfect domain where the industry can actually seek out that expertise from academia. One of the advantages of doing that is that much of the research in terms of building the models and the understanding has already been done through funding from government mechanisms. And subsequently the costs that are associated with it will not be so much as, as it would have been if you had to sustain a whole team of researchers and, fund big HPCs and things like that, right? So I would really encourage any, new space startups or any industries to seek out those expertise. If you need any intelligence on space weather, talk to me. Look out for expertise within the country and outside, and interact with agencies like ISRO and the academia. I think this is a fantastic domain where there can be cross interactions and exchange of knowledge.
Right, so the startups can lean a lot also on the bedrock of expertise that has already been built up.
Yeah, just one little point from me. As Dibyendu has highlighted, through InSpace, that has been highlighted during our inaugural session. InSpace provides a single window to the capabilities that ISRO has. And ISRO has a lot of in-house developed software, that is homegrown softwares for launch vehicle modeling and simulation. And that is available to anybody who really wants it And but they are not a single tool kind of thing as Kartik was saying. They are all distinct software elements that are playing into a trajectory design and structural design, the finite element modeling, then the CLA analysis, thermal analysis. We have grown our own softwares. SDK also we use for the other collision studies. So all this software as well as the expertise to use them properly is also available with us. So I think the startups will be able to tap to this potential that is available with us.
Can I say one more?
Sure, go ahead.
So it's great to know that ISRO and the association has these tools available. But what we are saying is that our software from Antaris will provide API services that will interact with all these dissimilar tools, make it simple for you. That is the goal. Goal is like provide a software platform and those APIs interact with this. So it's great to see that those tools, if they're available for users, then as we make our software available, as even open source some of them, then those APIs can be used, and altogether you can have a simulation environment where you can not only just do the hardware-based simulation, but also complete mission lifecycle simulation can be done in the cloud.
Great, thank you. I think we got a good range of answers to that question. So are there any burning questions from the audience? Because I don't want to save it right to the end in case there's somebody who wants to ask any of these speakers something based off of something they've said or hasn't been addressed yet. Yeah, and please do just briefly introduce yourself as well so the speakers know also a little bit of context to your question.
I'm Nikhil Arora and I am from InSpace. So I was just listening to all the talks. Now this virtual softwares, the virtual prototype and actual simulation, there's a little difference in that. The virtual prototyping is just a digital twin, but it may not be in the same environment or same physics which we are working. We do simulation and modeling to reduce the iterations. If I want to develop a product, can I do it in one go without a zero iteration? So if I am able to simulate it 100% properly with all the physics included, then I can directly from the virtual simulation to product, I can get in a single shot. But if there are any mismatches, if there are any problem, then I may have to do 1 or 2 iterations, which startups cannot do it. If you take example of SpaceX, after 3 or 4 launch, NASA has given them billions of dollars to reignite them, but which is not possible with all the startups. So the simulations tool have to become more and more stronger so that from prototype to production, it is a zero iteration. That is the only goal here. So because here all the softwares have different domain, like SDK cannot do alone anything. SDK plus Solis can only do the complete simulation of actuators and actuator sensors. So one software cannot do the thing. If you come to thermal or stress simulation, like even the FEM methods are there, one can do a good thermal dynamic thing, other software will do thermal thing. Lot of APIs may be required to connect all those things as a complete ecosystem. Now this complete ecosystem when you are doing, whether it will be open source or not. If it is open source, then only it's good for the startup ecosystem. Again, it is a costing. If you see the cost of these softwares, it goes in crores.
Right, so I think maybe to succinctly describe the question, this holy grail of a zero iteration design, is it possible? And if yes, how far? How many years away are we from zero iteration design? And if it's not possible, what is the closest approximation that we'll get to zero iteration design?
Maybe, can I add something to that, it's an excellent question. Therein, it actually depicts the real difficulty about doing things in space. We start our simulation classes by saying that the models are pretty useless because on its own, a model is a useless thing unless an expert uses in the way that the model is expressed to give it. As you told, the actuator point you mentioned, an actuator can be simply y plus y is equal to x into k, that it can be a simple model. It does good for certain design team. He needs only that much. Okay. The other team requires a frequency response. So you add more equations to the model. You make a model which gives you a frequency response as well as a gain. And that is good for the control people. Control people are happy with the gain as well as the frequency response. The moment another person comes, he says that this is not sufficient. There are friction effects and the stiction effects near the null. Near this range end, there is a saturation. So I need another model. So, in fact, in VSSC itself, we have 4 or 5 varieties of actuator models, and each designer community has to choose which is the right model he has to use for the actuators. So, unless that the expert chooses the right model, he may run into difficulties when he actually tests the system in a combined environment.
So the expert is essential because you might end up with garbage in, garbage out, basically. So
unless you are...
Yeah,
so Kartik, would you like to comment on
Yeah,
that?
my answer to that is there are differences between a model-based simulation versus real simulation. The model-based simulation we talk about is like what he's saying, if your input is garbage and output is garbage out. But imagine a place where you're simulating with your actual component, actual subsystems, actual hardware components that are going to be flying on a target spacecraft. If that is available in the cloud, and if you're able to connect it wherever you want, let's say your payload is in your lab and reaction wheel is somewhere and ADC is somewhere else, if you're able to have something in the cloud that actually connects to all these subsystems, and we're running through a model and simulation, you're running all your orbital analysis on top of that, if they're all combined together, then your zero iteration, digital twinning can happen. So that is the path that at least we are recommending. That's what we are proposing. Our model-based simulation is hardware in the loop. You can have your virtual satellite in the cloud. You have hardware in the loop. You connect from wherever you want. And when you're really trying to take the same code base, flash it with your real target hardware and fly, then it is the real digital twinning and real true twin simulation app happening. So that will be available pretty soon.
So Dibyendu, I wanted to just ask you something because I think, as you pointed out, the environment is critical towards our understanding of systems behavior. So how knowable is space weather? And given the stochastic nature of environmental factors, how can we contend with the unknown unknowns that play a role in determining criticality of systems? Is there an approach that you've already developed or you have in mind that'll get us close towards this zero iteration approach, or is it fundamentally not possible given that the space environment is unpredictable?
Yeah, so I was just going to answer that question in context of the other participants here. A zero iteration black box model for space environment is impossible. You need to have experts in your team to understand what is going on. I would cite a very recent example. You have, perhaps all of you in the business have heard about the extraordinary loss of 38 SpaceX Starlink satellites to a geomagnetic storm in February of this year. And this was a very moderate storm. This was not extreme space weather event. So I am leading a team at SIA-INDIA Kolkata and NASA Goddard and Predictive Sciences in the US to understand what really happened. And it's very unique, the set of circumstances that Starlink faced in terms of their strategy for inserting a satellite at very low Earth orbit at 220 kilometers and then boosting it up. It didn't work in this case because they really launched into a moderate geomagnetic storm, which enhanced the drag on the satellite. And the satellites have a ballistic coefficient with a very high area to mass ratio, which didn't really help matters at all. So increase the drag further and make them decay before they could really boost them up and recover them. So this is a fine example of how every situation could be different. And you have to be actively working towards mitigating the space weather events. One of the things that we can't do very well in terms of predicting space weather is predicting solar flares, which are the most intense storms. The National Academy of Sciences US estimates that if you have a storm, in similar in nature to one that happened in 1859, which is known as the greatest storm in the recorded era, there will be trillions of dollars of damages. We heard today morning that the space industry is $1 billion, $50 billion. Why trillions? Because that kind of a storm would actually wipe out any interconnected power grids on Earth also. So that report is widely available, it's in the public. We just hope that we don't get something like that, but this is a few times in 500 years you expect those events. And the more dependent we are on space-based assets, we must contend with space debris and space weather or space situational awareness. And here I think there is, your insurance companies are going to start worrying about it, right? So we are going to sell this intelligence to insurance companies because they're going to assess your risks when they underwrite your satellites, right?
Right.
So I think at some point in time, the space weather industry needs to wake up to where you are in space and how it's changing. And this is dynamic. There is no black box that can help you sort this out.
Right, and if I read between the lines, investing in expertise is essential, regardless of what we're able to model or simulate ultimately.
To the best of our understanding, and don't quote me on this, because I don't want to take any risk here, SpaceX did not have a space weather team on board. That's to the best of the understanding that we have found out.
And Renuka, would you like to comment on this this holy grail of zero iteration, simulate once, build, operate, and you're done?
Yeah, so I would say a couple of things. So first, certainly in other industries, we've seen it. So if you take, I think there's a published paper from BMW where their aim is zero prototyping. And of course the idea with that is you still have to have one prototype because you have to crash your car and make sure it passes compliance. But their aim is that by the time they have already done their tooling, so they cannot make major changes. So it's possible, but you also have to understand, and I think you pointed out this startup, it's not just the software, and of course I'd love to say it's the software, I come from this industry. It's also the knowledge, the expertise, it's the practices that are put in utilizing that software. And I think that's where people like Antaris and Dassault Systems are also incorporating industry best practices into our technology. Because earlier we perhaps just focused on making technology available, but bringing in those best practices, in our case we call it industry solution experiences, to allow people to accelerate that, because it's also how you use the technology. But there will always be this thing that if you you bring in new technology, and again I go back to automotive, you've developed something for an ICE engine, an internal combustion engine. That practice is not going to work when you bring in electric vehicles. So a lot of times the two things you might have to work out is if you're trying out something completely new, then your only hope is to go back in with your experts and work with these tools to model it. And of course, so this would be one thing to look out for, and the other is your basic assumptions. If in your assumption you didn't take in geomagnetic storm, then it doesn't matter how good your software is or what you're doing. So those are things that you just have to learn and hopefully learn from other people's mistakes so that, you grow from it. So that's what I would say. But yes, in other industries, we've certainly seen it, but over time that you develop your practice.
So maybe continuing on this topic and thinking a little bit about organizational resilience, since it seems what's emerging here is that software needs experts to operate it, what you're necessarily then introducing is that when teams are dynamic and people leave and join, they take knowledge with them, right? So from the modeling and simulation point of view and the development of software, what are kind of the approaches that are evolving that are enabling both the handoff and the capture and handoff of knowledge from experts within the software? And secondarily, what are the, in your view, in all of your views, the bottlenecks that have to be cleared to enable, for instance, true interoperability of models? Because if models are human-specific, then they don't necessarily automatically translate from one organization to another, right? And if we want to be operating commercial space across a variety of organizations. What are kind of the evolving technology side and best practices sides that you're seeing that will allow for a dynamic space industry to not lose knowledge along the way as we're building better and better models? Do you want to kick things off?
Maybe I will, and he can definitely add, I think, with his experience. So from our side, I think in the industry, especially in the simulation industry, the early focus was just on, better simulation technology, right? But we've realized exactly what you said, which is it can't be dependent on people. And what we end up doing, we've been seeing now for more than a decade, is a capture of the simulation process. So it's not just the actual simulation, but most organizations then capture that methodology and put it down into the software itself in some way or form. So that one, you also push this out to maybe people who are not necessarily experts in that domain. You don't want everyone to be a simulation expert, but they can utilize that best practice, run it, and then focus on interpreting results. So one is capturing that, and I think it's something we certainly do with our simulation process capture. The other is how do you ensure that, every time it's not a particular company which does this, and that's where we found this need for the industry solution experience, where with our experience of working with multiple companies in the domain, we kind of have a best practice already put in, but companies can then customize it to suit their individual needs, because that's something that they do. So this is something that we've certainly seen with trying to capture that knowledge. And I think in the aerospace industry they called it a silver tsunami, because at one stage they were seeing so many of the older senior engineers resign, retire, and with them, I think NASA at one stage said they cannot put a man again on the moon because all of those people have left, and that knowledge has left, and now they restart all over again, right?
Right. Maybe, Kartik, just to ask you also, building on a previous comment you made about open APIs and sort of the Linux approach or the Android approach towards development, what do you think we're critically missing right now to enable that level of knowledge capture and community and interoperability? Is there a single smoking gun, or is it a more structural issue for us to get to that point?
It's a more structural issue. That's it. She talked about the skill set capabilities. Forget about tsunami. We don't have those skill sets. If we really ask how many people can actually run STK today, you can number them globally. I really mean it. So that's how bad it is. So talk about that. And now if we talk about people who understand the space environments he's talking about, the simulation aspect of it, very limited skill sets. So this is the fundamental problem. There are two different fundamental problems. One is the supply chain issue that we are facing today. That's because of the dissimilar hardware, software. And then second thing is skill sets and capabilities. Those are two major issues. The way to solve this is like we strongly believe is an open platform, open API, so that people have access to these things, so that it increases the ecosystem. It creates more skill sets. That's how we solve the problem. And I think it's also behavior change. People think that space is hard and the very limited people can have knowledge base and access to it, but we need to really change it to make it very simple for people to use those tools, so that you don't need to be a space domain expertise to use those tools. So that's what we should head to. So.
Would either of you like to comment on this topic?
Maybe a quick comment that I think it's very difficult for the industry to build up modeling expertise in every different domain. You have to worry about 1,000 little things, right? So again, I think here you have to really look at academicians or institutes or organizations which have a proven expertise in a particular domain, and have people work with them in a close synergy, so that you can have that knowledge transferred from those organizations. I mean, an example I can give is the United States NOAA Space Weather Prediction Center, which is based in Boulder, and they have many government employees who are paid by the government. They create this knowledge for the Americans, and many industrial partners, space companies work with them You just need to have perhaps one person who can liaise off with them to get that, transfer that knowledge about the space environment. So this is certainly possible for India and for new state, space startups to work with organizations which have this expertise, liaise off with them, instead of really investing, in all these little pieces. You have to get 1,000 pieces right, and you get one piece wrong, and that sinks you, right? It's a difficult job.
Sir, would you like to comment on how perhaps this is looked at from the ISRO side?
ISRO, I should say that we had almost maybe three generations have gone through this. And as Ms. Renuka was highlighting, we have a set of good practices and the kind of way that each software has to be used and its limitations and the interactions. They are all captured in the way that it's well documented also within us. So the transfer of the competence happens as there is overlap between people actually. It is not that one full set goes out and another new set comes in. And for any industry that is primarily driven by the technology, there is no way that a novice can come and just start doing things. That is not at all possible actually. And to have a simulation software which captures the entire thing is like, as you told, it's a holy grail and good. But the point is that the expertise out there in ISRO, it is there, in academia it is there. It is the only thing that a startup has to do is to ask the right questions and find out what they want to find out. And who are the people who are going to help them out. And I think we can always put together a national directory of experts and the expertise and the software tools available in both in government institutions as well as in the academia to make the things easy. I think already ISRO has done a bit of it, and we have a set of a directory of experts and the capabilities that are available within ISRO for the startups to actually tap into. Only thing they need to know which one they want to contact. Yeah, that's all.
Great, thank you. So we're actually already nearing the end of a fascinating panel. I think there was one more audience question, if I'm not wrong, and I'd like to ask if you could keep the question relatively straightforward and short so that all the speakers can get a chance to answer before the session closes.
Absolutely.
So please introduce yourself also briefly, if you could.
Sure. This is Rachit Bhatia from Leo Labs. And I wanted to, it was interesting discussion about how there are gaps which can be filled. And there was alluding reference to data, but I think there was not much discussion about data-based modeling. And second thing, I think there was discussion about API, which Kartik was referring to, but there was not reference to closed loop feedback system coming from operations. Because as Leo Labs, we generate a lot of data for tracking and monitoring and conjunction risk, which has helped companies like SpaceX in ensuring that newly launched satellites, especially in during transporter mission, stay safe. So I would like to hear more about that from the panelists.
Sure, so maybe to summarize the question, there's software and there's data, right? And so software on its own is somewhat of a skeleton. So I think maybe, yeah, if you have comments on the importance of data, the role of data in between different stakeholders, and then particularly also providing this feedback mechanism right upstream so that designers know if they've made the right choices, what kind of environmental factors they perhaps missed. Do you want to perhaps comment on how data sits close to software?
Pass it on to Renuka too. So the way I see this is like, you're absolutely right. The simulations, we talked about zero simulation, all those things. There is a pre-launch and post-launch aspect of it. So we do systems engineering as a pre-launch thing, the satellite system level simulation. But the orbit perturbation changes every day, as we all know. The data keeps coming. So the way we think about it is like, so we have it's called true twin in your virtual satellite environment. And if you have data coming back from the orbit, if they're fed back into the same true twin, and if you're constantly running through this testing or simulation, then you can get close to what you're seeing in the space, not exactly the same thing. So that is what it's going to happen, right? So the true twin is like not just simulating before launch, but there is a CI/CD is happening, continuous integration, continuous development, getting this data back to the virtual satellite, and then you only change those things that impacts based on the data-driven model. So that's what we believe in. That's what we call true twin in the cloud. So with that, I'll pass it on.
Renuka, would you like to comment on how you look at data and the role of data sitting side by side with the simulation software?
Sure, and I think he covered quite a bit of it from our side. Definitely, especially in the initial stages, the data is important because it's what's defining, for instance, your material model. It's what's defining the loading. You need to understand that you're looking at a harsh environment. You know, what is the, say, magnetic interference you want to consider. So that kind of data, some of it is even subjective, but you have to take certain judgments and apply that data. So that's the initial design phase. What you're asking for, I think I agree, later during operations, you can feed it back to the same virtual twin model and then see how that behavior, what's going to come out of that behavior, and does that have an impact on its performance? So that aspect can be brought into your virtual twin, and that's the idea of the virtual twin, which is you keep enhancing it throughout its life so that you understand certain adverse effects, and then later in the history maybe it's going to behave a bit differently because it underwent something else as well. So that feedback of the data from your real-time system is something that's possible. I think companies are doing some of it in other industries as well, so we see that.
So maybe, Dibyendu,
this is true, the database is very important, and after each launch, if I take the way that we do the launch worker design and launches, each mission provides a whole set of data, and that goes back into the models. And every time we find that there is some tuning that is required for the models in order to capture that what has actually happened in the flight. So this is a continuous process, as Renuka has rightly pointed out. It is a continuous process, and after a while you get to have very good models for whatever that you have already experienced, but still you may find a surprise when a new situation, a coincidence of situations comes. Yeah.
So last but not least, Dibyendu, we were talking earlier about publicly available space weather data, right? And I'd like to ask you, looking at, for instance, the infrastructure in India, what would you like to see in terms of the availability of space weather data, the access to it, and the adoption of it by institutions in India, new space teams, etc.?
Yeah, so I would like to fold in your question with the question that was asked by one of the audience members. I think it's a fantastic question because we talked about simulations, but we never really talked about what if we don't really have the right physical understanding, machine learning and artificial intelligence models, right? In space, we have a wealth of data from various satellites, starting from NASA, ESA, ISRO. In fact, if you go to our space weather prediction website, just do a Google search on SESI, space weather, you should get the website. Our solar flare forecast is run by machine learning models which has been trained on last 10 years of data, which is gleaned from NASA satellites. So what I would like to request, we have people from ISRO here, we have perhaps people from various organizations, is a lot of data is lying inside your organizations that you can make openly accessible to the public. And this ought to the scientific organizations or people who need it. And in this data, there is history of experience of interactions between spacecrafts and space that is completely undermined right now. There is a wealth of data to be mined, and if you put it out, we can mine it. There are other people who will mine it, and there is a lot of intelligence that needs to be cleaned out from there. And in terms of space weather, I think what we really need is we are really, space is huge. We are really scratching the tail of the elephant and trying to figure out the elephant. So if we can have a slew of satellites which surrounds the near Earth space environment, we will get very nice picture of global space environment. And I think in this, the new space startups, satellite industries have a big role to play, because you're not talking of 1 or 10 satellites here. You're talking of thousands of satellites, which are, which have a certain lifetime, and we keep on replacing them. I think the space industry and ISRO, other space agencies have a big role to sustain this understanding of space weather going forward, because this is a dynamic environment. The need to do this will never end.
Great, thank you. So we've run a little bit over the scheduled time, so I'd like to kind of close out the session with a few words before we break for lunch. So I think what we've heard today is that there's a lot more to modeling and simulation and risk mitigation than just the bare bones software that's being developed. Although on the software side, we've heard that there's a lot of interesting developments that are happening. There's this also systems of systems approach, I guess, even to thinking about modeling and simulation and the role of the expert, the operator of the models, and knowledge capture, and finally also how data that is both coming back from the real world, but even simulated data, plays a role in enabling us to more rapidly develop reliable and secure space missions. I think that there's a lot more to be said about this. In fact, I had about another 1 million questions lined up. So what I would encourage you to do is, after this session, is reach out to any of the speakers if there's anything particular that they've mentioned that you want to discuss with them further. And also, I would say, think about ways in which perhaps in your daily work you can contribute towards us building better, more robust, more open and accessible modeling and simulation infrastructure, and ultimately, as a result, a better space industry. So I'd like to thank the speakers for their contributions, and the audience as well for your questions and your attention, and enjoy your lunch.
Thank you. Thank you all.
Thank you.